work and energy principle method, right? So for that, let me pose the second problem. So where you see there are conveyor system. So these are all the rollers. In this roller, you have a conveyor, and that goes around this like this. So this is a big conveyor in an industry which is used to have a material handling. Our finished products are conveyed here. There are finished products conveyed here. So this is traveling here, and then as it comes, it will be transferred to another unit. So look at this RAM slipping. So this RAM, semicircular RAM. Semicircular RAM. Right, this RAM of a radius. So as this has been coming here, it is conveyed, and this is going to slide on the smooth surface, and it is going to leave at one point of time from here. So if you look at that sleeving here from the center point, what is this angle that's going to leave? Theta. That's what you have to find out. So let me read this statement of the problem. Packages having mass of 2 kgs. Each package here has a mass of 2 kgs are delivered from a conveyor to a smooth circular ramp. This is a smooth circular ramp with a velocity of 1 meters per second. So at this point, when it comes, and it's going to go into this, right? So here the velocity is 1 meter per second, each packet. So if the radius of this ramp, this radius R is 0.5 meters given. Determine the angle theta, determine this angle theta, which is theta max, maximum angle, at which each package begins to leave the surface. At which each package begins to leave the surface. Begins to leave the surface of the ramp. That's the question. So you have to find this, determine this theta is equal to theta max for this given condition. So there is a conveyor system, the finished product box are conveyed, and it is to be transferred to the other place. So you have here a provision of circular smooth ramp. So this is conveyed with 1 meter per second, as the conveyor belt speed is 1 meter per second. So this comes on the smooth surface, and it won't go along the surface and fall here. It will leave at one point. So what is this angle theta maximum at which the delivering package of 1 meter per second speed comes out, will leave this. What is that angle theta is what is asked. So the mass of each package is given 2 kg. So that's the question. So how do you start solving this problem? Yeah, Stevenson, how do you start solving this problem?
Yes, sir.
So using conservation of energy.
Yeah, you can say conservation of energy, or you can also say work and energy principle automatically.
But there is no friction and everything.
Conservation of energy principle, as there is a smooth surface, right?
Yes, sir.
Yeah, so it is work and energy principle if you apply even in conservation of energy in a system where it is conservative system, it is automatically counting the work done from position 1 to 2 by its potential energy change. So you can always say you are applying work and energy principle. So when you apply work and energy principle, what is that you will be able to get? I know at this point, this, let us say this is position 1, right? And this is position 2. So I know what is the velocity with which it is leaving, and that will be dictated in terms of theta now. If I know this theta, then I know what is its value, but I know now velocity in terms of theta. So I can get one equation which relates my velocity of package leaving. But I have one equation in my hand and I have theta. So how do I go about solving? Then what should I do? Then I should apply Newton's law and solve the problem, right? So let's first find out what is this velocity as this package leaves, applying work and energy principle between position 1 and 2. So if I apply that, what is that kinetic energy at position 1 plus work done from 1 to 2 is equal to kinetic energy at position 2. So here kinetic energy is half into mass of the package is 2 into 1 square plus work done from position 1 to 2. So how do I get what is that work done? Since it is a smooth circular ramp given, it is a conservative. There is no energy loss. There is no frictional force. So this comes, there is a normal. There is a normal and weight. So what is the work done? Since here is the force is only the force which is mg, weight of this, and there is no other external force, and this is position 1, this is position 2, so there will be a change in elevation. So that would be required to calculate work done from 1 to 2, and it is independent of the path followed, right? Work done by the weight. So I can find out now what is work done from 1 to 2, as there is only one force that is there here. Right. So what is that equation? So that's going to be
So potential energy at
change in potential energy.
Yes,
so you have to find out this distances now. So this distance. So how do you get this?
Using
Is
R and
radius,
theta.
and this is r cos theta. So r into r cos theta. So it is 2 into 9.81 into r minus r cos theta, right? R minus r cos theta, and that's equal to half into m into v2 square. So m is 2 here. So now I would have r is here 0.5. So I can just solve this. So I will have here it's 1 plus 2 into 9.81 into 0.5 minus 0.5 cos theta. Other side it is v2 square. So I get v2 square equals this. So what is that value? So if I simplify this, I will have
9.81 into 1 minus cos theta.
Yeah, so this is 1 by 2 when I take, that will also go out. So I will have 1 plus 9.81 into 1 minus cos theta. Let me call that as a theta max, which I need to find out. So this is one equation. This is one equation. So now I have to find, say now one equation I have this. This is a conditional problem. What is the maximum value of theta? So now how do I solve that? I know now this block is actually translating in a circular path. So it's a curvilinear translation. So this will be subjected to an acceleration, and that acceleration is a centripetal acceleration that you have. And you also have a tangential component of acceleration. But what is important there is, as this leaves this, what is the contact normal? That's 0. So I'll have to draw now. I'll draw a free body diagram of this block at position 2, and that will relate to my normal component of acceleration. Right? So how? So I'm just going to draw that what is there on this position 2. So let me just. So this is a circular ramp. So this is the position where it is going to leave, and this is the center. So this would be normal line. So here my free body diagram would be mg down, and it is having contact here. So let me put that as here normal n. It is about to lose contact. That's the point of leaving. I'm just putting it a generic way. Maybe I would consider this before it is reaching theta max. So it is at an angle theta. If I consider, I'll have this n appearing, and then that's what is equal to. If I put again this diagram. What is that effect force here? Is MAN, and MAT. That's what I have it. So this will help me to solve further this. Here I have, these are the only forces. So this is the direction. Let me erase this line because that may mislead you. This is direction of velocity. I remove it. I'm just drawing free body diagram of this block at an angle theta from the delivery to the ramp from the conveyor. From this is position 1. Maybe position 2 is somewhere here. Position 2 is somewhere here. I'm just drawing it in between. So this is what I am interested in finding out, which is theta max. So if that is so, I just now look at this scenario here. I'm going to write now this. So by taking equation along this direction in the normal direction, sigma F is equal to MAN is a Newton's law. Then I have here for this free body diagram, it is minus N because I take this is positive for convenience. So minus N, and I have my weight component, that's 2 into 9.81. And if this is angle theta to vertical, so I draw this angle theta, so this angle also is theta, right? This angle also is theta, so that's going to be along this cos theta, that's equal to 2 into AN. That's one equation. So now in this equation, when theta equals theta max, what is that you understand? When theta equal to theta max, this n is 0. At theta equal to theta max, the normal should be equal to 0 as it leaves the ramp. If this is your understanding, then what is that time velocity? V is equal to velocity V2. Right, so what will I have in this equation? This is generic equation. In this equation, n is 0 if I substitute, and this becomes 0 if I substitute. That's going to be 2 into 9.81 cos theta max. Now that's equal to 2 into what is AN? It's V2 squared by rho. Rho here is radius of this ramp, that's 0.5. So this we have to put in. So this solves for V2 square, that's equal to, so this become 4 and goes down, so it's being 4. So it is, so this 2 goes off, and V squared by rho, this 0.4, 1 by 2, so this 2 divided by this, so it is 9.81 by 2 cos theta max. This is what is my V2 square. So this is my second equation. So we had already first equation here, and I have second equation. So in this now I can substitute, put this V2 square by that, comparing 1 and 2, I can solve for cos theta max. That's all. So then what is that my equation? So it is 9.81 by 2 cos theta max square, that's equal to, sorry, that's not square. What is that equation? 1 minute. Just equation 1 is V2 square. So what do I have here? Is V2 square. So it's not square. So that's equal to what was the other side that I had is 9.81 into 1 minus cos theta max plus 1. So solving this, I would be able to have my cos theta max value. Yeah.
Sir, I have to in the next class, sir. Can I leave?
Yeah, you can go. Now it's only 3:50. You have 5 more minutes. Anyhow, you can leave. I will download the attendance. Later on, you can look at for your assignment writing. You can
Yes,
leave.
sir, yes.
I will download the attendance later. Yeah.
Thank you, sir.
Yeah. So this cos theta max would be now will be 0.735. That's what I have here. So you have theta max is cos inverse of 0.3735. That's going to be 42.72 degrees. So I can of course find out now what is my velocity of leaving. So that's equal to this the root of 9.81 by 2 cos 42.72 degrees. So that's going to give me 1.898 meter per second. So which is with the direction of this. So now what is this direction? Look at direction here. This is the direction. This is the direction to what you are writing is if this is theta max, then you will have here to the horizontal the same, because this is normal and that is to the horizontal theta max, right? So you know that if I draw a slope and if I draw a normal to that, and that will have to the vertical same angle. This is what you have to understand. So if here I consider theta max to the vertical and this is normal, so that will have to the horizontal this. So the direction of this velocity is this counterclockwise, clockwise direction 42.72 or 360 minus this measured from here. So that's what that quiz I had given you, so that whether you are knowing that convention of angular measurement. So anytime by default you are expected to measure the angle in counterclockwise direction positive. So if this is so, this direction is 360 minus this angle, or you can say this angle by pictorially representing like this. So this is the direction of this velocity with which it is leaving the ramp. So you see, in this case, independently solving by work and energy method is not sufficient. So you have to seek always both equation, Newton's law as well as this, right? So this is again a good problem. So let me pose the third problem as a homework problem for you to solve that by work and energy principle, and then I will complete today's class. So the problem number 3 is again here